Today we're going to learn how to graph higher order polynomials, which just means a function with a power higher than 2. We've already looked at end behavior, what the function's doing when x gets really large or really small, and we've looked at finding zeros by hand. Today we're going to look at how to get these on a graphing calculator. Multiplicity is simply when a zero is a turning point. If the zero repeats, for example, this zero here happens twice, so that would be a turning point for the graph. Whereas this zero that only occurs once, the graph would cut through the x-axis. And we'll see both examples as we look at our problems for today. So our first example, we're going to have an idea of end behavior before we graph. So we know that when we look at the graph, it is what we think it should be. If there's some sort of disconnect, we either need to figure out what we did wrong with end behavior or what we did wrong when we were typing the graph into the calculator so that they match up. First of all, the highest power on either term is 3, so this is an odd function. And then the leading coefficient, meaning that number that we're multiplying by the term with the highest power, is negative. So this graph will look like a snake, but instead of rising to the right, it will fall to the right. This one we're going to run through the zeros by hand. The second one we're going to look at the zeros on the graphing calculator. So we set our function equal to 0 and solve for x. We have a common factor of x squared, leaving us with 5 minus x. Setting each piece equal to 0, either x squared equals 0 or 5 minus x equals 0. For our first zero, it is repeated that x is being squared. So the 0 of 0, 0 is a turning point for our function. Solving our second equation, instead of subtracting 5, I'm going to add x to both sides so I can solve this in one step. My second 0 is not repeated, so 5, 0, the graph will cut through the x-axis. Let's take a look at what this looks like on the graphing calculator to see if there are any other turning points that we need to know about before we graph our function. So as a reminder, we go into the y equals and we type in our function. I already have this typed in for you. I also already have the second one typed in, but notice the equal sign on the second one is not highlighted, so it will not show up when I go to graph this. When I first graph, I go to zoom standard, which is number 6, so you can just hit 6. What that does is it gives you a window from -10 to 10 for both your x and your y. Typically, we should see our graph fall into this window. It looks to me like we have a turning point that we can't quite see, so I'm going to go ahead and increase my y max because I need to see what's going on higher up. So I'm going to look at what happens if y max is 20. And now my graph fits in the window. So we see the turning point at 0, 0. We see the graph cut through at 5, 0. And we just need to calculate this last turning point so we can get a sketch of our function. Remember, we're going to go into calculate, so I'm going to hit second calculate. I'm looking for a maximum value. It's going to ask me for a left bound, so I like getting fairly close to the turning point off to the left, and then just past the turning point off to the right. For the guess, it doesn't really matter. You can just hit enter, and then it will calculate. We have another maximum or another turning point at about 3.3, 18.5. We now have all the key pieces of information to get a sketch of this function. I know that I need to go to at least 19, so I'm going to scale each of these by 4 so I can get up to 20. And because we do want to know a little bit what's happening past that 0 of 5, I'm going to scale each of these by 2. Plotting the zeros and that turning point at just past 3, just past 18. And we're just looking for a sketch, so we don't need any other precise points. Our graph is falling to this turning point, rising to this one, and falling through that second 0. Of course, make sure you have arrows on your graphs as it does extend forever in both directions. With this function, the only thing we're going to do by hand is the end behavior, and we're going to take a look at all zeros and turning points on the graphing calculator. Our highest power is even, and our leading coefficient is positive. So with an even power, it's a parabola type shape, and a positive coefficient says our graph would be opening up. Pulling up the graph on the calculator. When I go back to y equals, if I want to save this one, I can just shut it off. We don't need to see what's going on with it for now. And then hitting enter will turn my second graph on. As a reminder, to get these powers, you use the caret here. To get a squared power, there is that function off to the right. And then this key right here will give you your x value. So again, I'm going to start with a standard window and just see what happens from -10 to 10. And it does look like I can see all of my turning points. I probably want a little bit more detail here. It looks like I can probably make my x go from -2 to 2, and my y, maybe I can get away with -6 to 4. There's really not much going on up there. So I'm going to change my window just to see a little bit more detail. And this is kind of a funky graph. We definitely have a turning point here, and then it just kind of waves a little bit. There's a little bit of a turning point here and a little bit of a turning point here. So we're going to see what we get when we use our calculator. First of all, I'm going to calculate these zeros. Same option right here, calculate. This time I'm looking for my zeros. So I'm going to go to the left of my first zero. You just have to make sure your y value is positive. And then I'm going to go to the right. You just have to make sure your y value is negative. Now I did see it click the 0 exactly, so let's see what happens when we calculate that. And it is -1, 0. All right, let's calculate that other 0. This time, because of where the 0 is the left bound, our y value needs to be negative. Our right bound, the y value needs to be positive. And this time we got a 0 of 1 1/3. Another key piece of information is the y-intercept. On our last graph, the y-intercept also happened to be a 0, but on this one it's not. Unfortunately, the calculator doesn't allow us to calculate the y-intercept. It's not one of our options. So we just go to the graph and we can hit the trace button. So without hitting second, I'm just going to trace. And I want to get as close to an x value of 0 as I can to see what my y-intercept is. Lucky for us, we did get that exact y-intercept, 0, -4. All right, let's start finding these minimums, and maybe I've got a little bit of a maximum and another little minimum over here. So I'm going to calculate, first of all, my obvious minimum. To the left, enter. To the right, enter, and then we can guess. So our first turning point is about -0.4, -4.9, or roughly -5. All right, so notice I have the zeros and the y-intercepts. So now we're going to get our turning points recorded as well. So in order to determine if these are actually turning points, I'm going to trace along the graph and see if the y value ever starts to decrease after this point, or if it just continues to increase. If so, I'm probably just going to try and trace to these points that are kind of shaping the graph a little bit, because otherwise it won't calculate, it's not an actual max or min. So let's see what happens as we trace along the graph. So I'm going to slow down here. Our y value is still increasing. And we got past that little hill. And here our y value is still increasing. This was a nice point right here. It's not perfectly at that little hill I was looking at, but it's definitely a point that we can use to help sketch the graph. And then right here was kind of another point where it was changing a little bit. So 0.5 roughly and negative 2.8. And then right around here was another point. So 0.8, negative 2.4. For scaling on my y-axis, I'm going to count each of these as 1. But on my x-axis, I have a lot of half points and decimals, so I'm actually going to scale every other one of these as 1. So each little tick mark is 0.5. So this is 1, 2. So my graph goes out to 2.5 on either side. So plotting my zeros at negative 1 and about 1.3. And then I had a y-intercept at negative 4. My turning points, negative 0.4 and just about to negative 5. And then I had those points where a little something was happening. It looked like it was kind of wiggling a little bit. So 0.5, negative 2.8. And then 0.8, negative 2.4. All right, so then I'm going to sketch my graph. It was opening up. And of course, arrows to indicate that it continues forever. Make sure you come to class with questions, especially if you didn't have a graphing calculator in front of you. We will get one in your hands in class.